Hello everyone. My name is Najee Gaines, um, senior biology major, chem minor. This is my final bioinformatics PowerPoint presentation. And the PowerPoint presentation will actually be focusing on African American men with prostate cancer in the United States. So, the introduction of study. We're going to start off at the number one fact of it's a hereditary linkage. It is an ideal that portrays the structural planning of genomes and variety between populace. So basically, this is meaning in a sense that depending on location, we see a definite comparison between location of patients and individuals who have been diagnosed with prostate cancer who are also African American men. Next, we will start off and just say that all hereditary variability starts locally as another change independently and are geographically confirmed. There is a connection between the heredity variations found in one's geographic distinction in contrast with those who are discovered somewhere else. So that's what I was stating initially. The variations that are the normal crosswise over for humans populace have a tendency to be older and go back to the seasons of human development for about around 100,000 years prior. So that's important. And African Americans are an admixed populace, which implies that they have a late, I'm sorry, I'm a little sick, which implies that they have a late bling familiarity gatherings. In this way, for the illness that are disproportionate, influencing the African American group and culture, essentially, obviously, in African American men, there may be attribute rarity variations that may be specific to only African American men to the increasing risk. Understanding into the dangers of loci, to explore is important as well. So this is just a small little snippet of what my R studio kind of represented, just for quick little few touch bases. Obviously, the CHR's chromosome, we have, the SNP, that's the SNPs. We have age incorporated into the database, as well as the p-values. We have the OR, that is just, the odds that a mutation will occur given in a particular, exposure. Obviously we have the p-value, which is the probability that a mutation will occur due to a specific change. And hopefully everyone knows what the SNPs are. They're just single nucleotide polymorphism. So that's just a small little overview of what the initial data look like. African diaspora. Obviously, the African people started off over in Africa, but it was exported through history as well as other migrational movements that African people, which turned into African American people, and etc., ended up in other places of the world. So it's definitely a factor of being incorporated into translocation, which is simply initially the key. Next, we're going to start off with graphs that I've actually been doing in the R Studio. So the first graph is a MDS plot, and that was in the Geneva database, and that is a multi dimensional scale plot. Um, this graph basically clusters the groups of controls and populations that took action in a blink. The multi-dimensional scalar graph is basically the meaning of visualizing the levels of familiarity in individuals' causes of a data sheet. It refers to a set of related origins, technology bases, used in informations to visualize in a particular to display information contained in a distance matrix. So, and this is my MDS plot. I wish I could have gotten it in color so it could have actually seen what the actual clear results. Obviously it would be nice diagnosis in color, but you can see that it's extremely populally congested over in the left side of the region of the graph, and this was done through Geneva. So we're gonna continue on. So the next graph I did was the Manhattan plot, and that was actually in the Geneva as well. This is revolving around the chromosomes that were used in reference of the negative log of the p-value. So a Manhattan plot is actually just a type of a scattered plot graph that is usually used to display data, which are in large amounts of data points that may include non-zero amps, as well as distributes of high magnitude values. For instance, we have the genome-wide association study and other familiar studies as well. So this one I did was able to get in color. This is the Manhattan plot, and this was done in Geneva as well. As you can see, it's evenly distributed in some of the chromosomes ranging from 1 to 24, but you can see along the lines once you get to 15, 18, 22, the amount gets less and less as far as the color association between the orange and the blue. Another graph would be the Geneva significance test. And this test is just representing the individual p-value cutoffs, the significance test, as well as the p-values, how they're in comparison to each other. You'll see that when you look at the p-value, there's down in the bottom left corner, there is a gradual
shift between the graph. You see that it is gradually accelerating along the way. Down at the bottom left corner, you see the significance test. It actually starts off very neutral, and then it increases gradually until it reaches its peak as well. So the last graph that we did would be the p-value histogram graph, and basically this graph just lets us know immediate sense of test behavioral of crossing due to our hypothesis, and immediately diagnoses some potential problem. It shows the distribution of mutations between a specific p-values, and due to their p-values, the p-values mutations, which results in clustering, and the plot then comes about through the different density levels. So you see the density levels here. As you can see, you see that it has the p-value down at the x and the density down at the top. You see that we have generally peaks between the 0.25 and the 0.50. Those would be our highest peaks, and it has the obviously incorporated with the Q value and the local value. So this is actually the end of my presentation. I thank you so much for watching. Currently, this research has not been finished or has any ending conclusions due to the fact that it is still being conducted over at Clark Atlanta University. So throughout what I've been using the data for, I believe that there should be research that should be further, because I do feel that there is a in-depth result concluding to why there is such a high risk in African American males. But overall, I enjoyed bioinformatics. I thank you, Dr. Quinn, for your time, Dr. Chen, for your time, excuse me, and I really appreciate all your help. So, thank you.